Start on 3.3 today. There are a lot of little details in section 3.3. So we are going to start today, and then we're going to finish it up another time. All right. So we're only going to do down to the bottom of the first page. So we're talking about imaginary numbers today. Have you heard of imaginary numbers before? Yeah. Yes? Okay, so an imaginary number happens when we have a square root and what's under it is negative. So by definition, what we're saying I is equal to is the square root of -1. So we are giving it that definition. So typically I don't use I a lot as a variable when you guys see me writing problems or coming up with solving questions, because I don't want to use it and confuse it in with other things, because truly to me I is always the square root of -1. Alright, so the next thing says I squared. So do you see how this is I? So I squared would be this same thing but squared. Well, what happens if you square a square root?
It normalizes.
Normalizes, equalizes, right? Like it comes out to just -1. So using our definition of what I is, I squared is -1. I cubed. I cubed would be the same as I squared times I to the first, because a 2 and a 1 would add up to 3. If we multiplied these together, I'd get negative square root of -1. Another way to say that would be -I. And then I to the fourth would be squaring this. So if we take I squared and square it, what is -1 squared? Just 1. So I to the fourth would be 1. And then it repeats. So I to the fifth would be the square root of -1. I to the sixth would be -1. Bless you. I to the seventh would be -I, and so on. So from here it just repeats and repeats and repeats. So the reason we kind of look at these first 4 is because afterwards it's going to continue to repeat over and over and over again. All right. Let's take a look at part A. We're going to go through these together. Most of them are going to be just simplifying for today. Take a look at square root of -16. Let's pretend it's positive for a minute. If it were a positive 16, what would you tell me it is for the answer? 4. So the way we're going to think about these today is kind of breaking them down into little baby bite-sized pieces. So if we think about taking just the square root of 16, I agree that it's 4. But based on the definition, if we have that -1 in there too, what did we say the square root of -1 is equal to? I. And so your answer would be 4I. Let's go down to part B. I'm going to break this one apart too. -1. So we've got 96. Is 96 a perfect square or square root? No, it's not on our list. Hold on. Okay, so we've got to start thinking about things that are perfect squares. Okay, and we could even make a list for ourselves, right? So 2 squared is 4, 3 squared 9, 16, 25, 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, and then 121 would be next. So I could continue on, right? I could keep going with 13 squared and 14 squared and so on. So my question becomes, 96 isn't on the list, but can any of these things divide into 96 evenly? So I can at least simplify and make the number under the root smaller. So see what you can find out. I think I found it. What divides in from my list nicely? Which one? 8? Which one divides in nicely? Yeah, so we're taking these and we're seeing which one divides nicely into 96. Which one? 16? That's the one I got too. So I'm going to break this apart again. Think about like breaking it into bite-sized pieces. So when you have little kids who are toddlers, you kind of cut their food apart and you give them little bite-sized pieces that they can deal with. This is kind of the same idea that we're breaking this apart. If I multiply this back together, I'll get back my negative 96. So I've got my negative 1 times the 16 times the 6. If I multiply it all together, I get negative 96. So I'm going to go through one step at a time and I'm going to evaluate each piece. What is the square root of negative 1? I. Now this next part is my perfect square part. What do we know the square root of 16 is? 4. Can I take the square root of this last bit and have it come out nice? No, it's what we call an irrational number. It will continue on forever and ever as a decimal. It won't repeat, it won't end, it's just going to continue on. So this is going to be my final answer. So when I ask you to simplify, sometimes you'll be able to get rid of the root entirely, like everything will simplify. Sometimes when you are asked to simplify, what's under the root just becomes smaller. Okay, we started with negative 96 and now we just have a 6. I wish there was nothing under there, but we can't simplify it all the way. All right, part C. We've got to break up and do both parts first. Let's take a look at this one. I'm breaking it into pieces again. Negative 1, and I want to find stuff that multiplies to 24 where something is a perfect square. So what's a number? 4 times 6. So do you see how I've broken it apart into my 3 bite-sized pieces? So typically it's going to be either 2 or 3 bite-sized pieces. Again, the first piece will be your negative. The next piece will be the part that's a perfect square if there is one. And the last part will be a part that isn't a perfect square. All right, let's break this one apart. This one doesn't break apart as much. It just breaks apart to the negative 1 and the 2. Because there's nothing that I can divide in that's a perfect square. Does that make sense? So right now I'm just breaking it into like the most basic little building blocks that make up these numbers. Can you zoom in a little bit more on that? I feel like it's not big enough. Okay. If I think about the square root of negative 1 by definition, what is it? I. Square root of 4 is? 2. And then the root 6 is going to stay and live on underneath. Over here. Square root of negative 1 is? I. And then the root 2 is going to live on underneath. Once you get it simplified, then you can multiply. So we want to simplify first. And then we're going to multiply second. So when you multiply, let me get out some highlighters. I'm going to use highlighters today. The things that are out front can be multiplied together. And then the things that are under the roots also get multiplied together. What would you get if you had 2i times I? 2i squared. I agree. Remember, whenever you have 2 of something like x times x, x squared. Y times y, y squared. Same thing here. I times I squared. Now, these we can multiply together as well because they're both under the root. What do I get when I multiply 6 times 2?
12.
Now, simplify first, then multiply, and then you have to check and see if you can simplify more. So you always have to look and see if you can simplify any more. So that has to be a question you always ask yourself. So again, with problems like this, simplify, multiply, and then go back to the simplify step and see if there's more you can do. What did we say I squared was in that first big box at the top? -1. So this is really 2 times -1, so it's -2. Underneath the root, I need to look and see if I can break that apart. So 12 isn't a perfect square, but is there something that is a perfect square that divides it?
Yes.
4. So this can be broken into 4 times 3. What do we know the square root of 4 is? 2. The 2 gets multiplied by this -2 out front, so I have -4, and the root 3 lives on. So this is probably one of the trickiest problems you're going to have all day, is going to be a problem like this where you can end up simplifying twice. So again, if you're wondering how I got the 4, I'm square rooting this 4. It's 2. When the 2 comes out front, it gets multiplied to this -2. That's how I end up with 4. Okay. What if you have a lot of i's? So that's another situation that can come up that we can also simplify. So now we're not in square root land anymore. We're looking at lots and lots of i's. So here's the way that I like to think about these. If it's even, do you see how I to the 32nd, 32 is an even number? Okay, so if it's even, what I like to do is rewrite it as I to the second, because I know what I to the second is. What's I to the second? -1, right? So if I go back to this list, I to the second is -1. So I'm going to rewrite this as I to the second to the 16th. Because do you see how if I do 2 times 16, I'll get back my 32? Okay, so that means this is really -1 to the 16th power. What's -1 to the 16th power? I have 16 -1s lined up and being multiplied. +1. It should end up being positive in the end because your negatives will cancel. Okay, so another way that we could be asked to simplify, besides a square root, is having lots of i's and trying to get down to a smaller amount of I. All right, next, -6 times 2 times -5. I'm going to start with just the coefficients. If I multiply -6 times 2 times -5, what am I going to end up with if I'm just thinking about the numbers? 60, yeah. And you can always use a calculator to help yourself. Remember, you have access to them on the quizzes and tests too. So -6 times 2 is -12. -12 times -5 is going to be a positive 60. And then how many i's do I have? 3. So I cubed. All right, now, I cubed was the same as what? -I. So I'm going to change this to -60i. So just like we want what's under the square root to be the smallest number possible, we want the exponent with our I to be the smallest number possible. F. All right, so first we need to square. So always think back through order of operations. Remember, if there are parentheses, we've got to do that first. So I'm going to leave the negative 4i alone out front for just a moment. If I square negative 7, so negative 7 times negative 7, what do I get?
49.
Negative 7 times 9? Did we say 49?
Yeah.
Oh, okay, I swear I heard 29 somehow. Okay, and then if I square the I get I squared. Okay. Now, we simplified them. Let's multiply these things together. If I do negative 4 times 49, what do I get? So I'm multiplying these things together because these are numbers I can multiply together. They're my coefficients. What do I get?
Negative 196.
Negative 196. And then I to the first times I squared would be I to the cubed. Again, when we're being asked to simplify, I want to replace it with the lowest exponent. So what can I put in place of I cubed?
Negative I.
So I'm going to put in a negative I in place of that because that has a smaller exponent. That has an exponent of 1. So if I plug in negative I, it's going to be positive 196I. Another way you could have thought of this, so if that was a bit much to process through, you could have thought of this staying as 4I, and this would have been negative 49, right? Because the I squared is negative 1. So this would be negative 49, and then when you multiply, it would give you the same answer. So again, you can think about going from here to here, or you can think about going from here to here. Either way, you get to the same spot. All right, next. We've got 2 more things on our agenda. Next thing is we want to be able to solve. And so that's the goal, and that's why we have these imaginary numbers, is so we can help solve for stuff. Okay? So, when I go to solve, I want to get the x alone. How can I get rid of stuff to get the x alone? Yeah, let's subtract away the 288. So I get 2x squared equals negative 288. Okay, I want to keep solving. How can I get rid of the 2 being multiplied to the x squared? Divide by 2. I get x squared equals negative 144. Okay, hold on. We've got to be careful. When we go to solve, what do I need to do to each side to solve? Square root. Oops. Do you remember what symbol pops up out front if I square root to solve something? Let's go to a super easy problem. Let's not even think about this one with the negatives and all the things for a minute. If I had x squared equals 9, what could x be? 3. What else could x be?
Negative
0 squared wouldn't give me 9.
Negative 3.
It could be plus or minus 3. Do you remember this plus or minus sign?
Yep.
Okay, so whenever you solve something and you square root along the way, or you take any even root, it could be a square root, it could be a 4th root, it could be a 6th root. Whenever you do that, you get a plus minus sign. What do we know the square root of 144 is? 12. And then because it was negative, what should I also have? I. Now, just like any other solving problem, if I were to plug that back in, I should get 2 things that are equal to each other. You don't need to do this, but I'm going to show you that it works. You ready? So let me try just 12i. So if I do 2, and I've got my 12i, and I square it, plus 288, it should equal 0. So this is 2, and this is 144I squared.
How do you do I in a calculator?
We're not going to use the calculators for i's, okay? So this is something we have to do without it. You can find like the coefficients and other numbers, like you can use it for other parts of the problem, but not for the I. 2 times 144 is
288.
288, I squared plus 288. What does the I squared do? Yeah, it's a -1. So negative 288 plus 288 equals 0. Is that a true statement? Yes. Perfect. So that works, and you could do the same thing by plugging in the -12i. All right, similar question for part B. We want to get x alone. How can I get rid of the 150?
Subtract.
Yes. Okay, I still want to get x squared alone. How can I divide it by 3? X squared equals -50. Then how would I get rid of the squared? Square root each side. Now, remember when you square root each side, that's when that plus or minus symbol comes up out front. All right, let's break this apart like we were doing in the beginning. I can break it into -1. 50 isn't a perfect square, but what divides in that is a perfect square?
25.
So x equals plus or minus, what's the square root of -1 by definition? I. What's the square root of 25? And then I can't take the square root of 2 and have it be nice, so it lives on underneath. So this would be my final answer. So we are kind of getting into the point where we're not going to get nice answers like 7 or 12. Like we're going to start getting stuff that has i's in it. All right. Last type of problem I'm going to show you today is that you can add and subtract imaginary numbers. You're going to treat I just like a variable. So treat I like any other variable. All right. They like to put their problems in parentheses. It's really not necessary. So there's nothing being multiplied. I'm going to drop away the parentheses. All you're going to do here is add your like terms together. Do you see how I have two things that are just plain old numbers? 4 plus 6 gives me -2. Then I'm going to combine my imaginary numbers. If I have 2i take away 7i, I'm going to have -5i. So again, we treat them very much like they are just a variable. Same thing with this one. We don't need the parentheses. We need to distribute that negative in though. So negative times a negative is a +2. Negative times a positive is a -3i. So I like to get rid of the parentheses first because otherwise there's just too much going on. If I add my constants, my plain old numbers, what do I get?
3.
3.
Second answer was 3.
Well, hold on. If I have -3i minus 3 more i's, what do I end up with? -6i. And I can't condense that anymore. Those aren't like terms, so I can't get like -3i as my final answer, right? Because this one has an I, this one doesn't. So they're not like terms. That's as much as I can condense it. Tomorrow we're going to talk more about how we can multiply and divide and do all sorts of other things. Today this was plenty, I think, because the simplifying to me is the hardest part. Truly. Okay?